And I'll shout out incesticide. It's one of my favorite methods. I love it so much. Oh boy.
Okay. This is actually the last section of the last part of the first section of chapter 9. So we will have our test on Tuesday over the first half of this chapter. And the second half of this chapter builds on the first half of this chapter, so don't think that this stuff's going away anytime soon. So yesterday we talked about empirical formula and percent mass. I said we'd come back to empirical formula. But what we did yesterday is we were able to figure out the percent mass of anything, regardless of whether we knew the mass or not. And why could we do that?
Because you had the...
Kind of. I mean, the reason why, whether you were given the parts or the whole, or whether you were not, the percent mass we said was going to be the same for in any compound because every compound has the same stuff that it makes up. Right? If I have H2O, it's always H2O. I always have 2 hydrogens and 1 oxygen. Last time I checked, the hydrogens always weigh the same, and the oxygens always weigh the same. I was waiting for some smart aleck to talk about the isotopes. Yes! The average of them does. Okay? I was waiting for it. I was waiting for someone to say it. Okay? Then we introduced empirical formula. And we said empirical formula was its what?
The basic.
It's simplified whole number ratio. And I began alluding yesterday to the idea that we can work backwards from percent mass to figure out your empirical formula. Why is that important? Well, a lot of times in a lab, you'll be dealing with stuff where you have some unknown substance. You don't know what it is. Okay? You have no idea what the substance is. However, you can put it into some high-level technology, and you can break it down and figure out exactly how much mass of each element it has in it. But you're going to have to do some work to figure out what the compound is. Thankfully, if you know the percent mass, you can work backwards to find the empirical formula of some unknown substance. Okay, and we'll actually also then talk about how you can determine what the molecular formula is after you found the empirical formula. So, that's pretty awesome to be able to figure out some unknown substances just by knowing a few math things and having some nice high-level technology. So, let's do that. Let's assume we're around today. Ooh. I'm going to get right after these problems. I was going to kind of work my way up to it, but we got 24 minutes, so let's make sure we get through all this. Okay. Calculating empirical formulas from percent composition. Okay. A laboratory analysis of an unknown gas has determined that the gas is 72.55% oxygen and 27.45% carbon by mass. What is the empirical formula? Okay. Now, yesterday we talked about how it doesn't matter the mass, the percentages always stay the same, correct? Okay? Doesn't matter. We can choose whatever mass we want and the percentages aren't going to change, correct? Okay? So is there a certain mass that might be advantageous, I like that word, advantageous for us to use to be able to take this percent and use it? 100. Okay? So I could say that I got a 100-gram sample of this unknown gas, don't know what the gas is. What would that tell me the mass of oxygen is?
72.55 grams.
Huh?
Not going down the line more, boys.
And then 27.45 grams. Marty, you're great. Don't let anybody tell you you're not great.
Yeah.
What?
What?
I just said like I'm not going down the hill anymore.
Yes.
Huh? Now, we've got this mass. An empirical form. What does an empirical formula deal with?
The simplest.
The basic ratios of what?
The elements.
The elements. Okay, so and right, that would be if we had our subscripts in their most basic simplified version. What do those subscripts represent?
How many of those?
So we would need, if we want empirical formula, wouldn't we need it in mole form? Right? Because if I got H2O, and I have 1 mole of H2O, how many moles of hydrogen do I have? 2. And how many moles of oxygen do I have? 1. So what do you think would probably be the most logical step then to do here if we have grams? Convert to moles. Okay, do it. Because what didn't yesterday we took a compound and we looked at the mole ratios and we converted it to mass, right? And didn't I say empirical formula is doing the opposite? I did. Let's do it. Anybody got oxygen's molar mass memorized yet?
16.
How about carbon?
12.01.
Alright. Well, let's do this here then. Alright. I don't hear many calculators thumping, beating, ticking, clinking, clacking. I gave you guys a periodic table right in front of you, so you can look at your periodic table and do this really quickly.
4.53.
Or which one? That one?
That's 2.29.
Okay, so our empirical formula is
What? That's disgusting.
does that make sense?
No.
Oh.
No, it's not. I'm just trying to point this out that this is not the final thing we have to do.
I was about to say.
Okay? That is not the empirical formula. However, is that a correct ratio? Yes.
Now let's multiply it by the avocados or whatever, and then let's simplify it.
Avocado, not avocado.
Why not?
Say avocado.
Simplify it. Why would I want to get into particles?
So then you
Yeah.
can simplify it.
No, I can do it a little easier than that.
What? Teach us.
Well, remember, we want the simplest ratio, right?
Yeah.
So if I multiply or divide by a constant number, it would maintain a ratio, right?
Yes.
Okay? What's the simplest ratio? What's the simplest number to be simplified to of all time?
1.
Not 0. 1. Okay. So let's take these two numbers here. And what would I have to do to get one of them to be 1?
Divide by one or the other.
Divide by itself. Okay? But I'm going to divide by the smallest of the two. Because they're both not going to be 1s, are they? It's not possible. That just won't make sense. So let's take this guy, divide it by 2.29. And in order to maintain the ratio, what would I have to do to the other guy?
Divide by 2.29.
So we know this is going to be 1. What's the other guy going to be?
1.978.
Which is approximately what?
12.
We found our empirical formulas, boys and girls.
Why was this so difficult?
I found it too.
Good job, Gabe.
Did you?
Well, I divided that
No.
times I got 0.5 is equal to 1/2, which is CO2.
I mean, yeah.
Yeah.
You could try it that way. This way seems a little bit stupid.
Okay, well, that's just fine. Whatever.
What is he doing?
Okay, well, it makes sense. That would be a logical guess. But are you seeing what we just did here? Why I divided by the smallest. Dividing by the smallest is going to give you your simplest whole number ratio, which we said is empirical formula, correct? And does it make sense why I would divide both by the same number? Why would I divide both by the same number? Yeah, you maintain this right ratio, right? If you in math, when you simplify an equation and you multiply by 2 to one side, you have to multiply by 2 to the other side, correct? Otherwise, it's no longer equal anymore. It's the same idea here. So what we simply did is we were able to take a percent of each and figure out exactly what the empirical formula is. Now, does this mean that this is the molecular formula?
No.
Doesn't necessarily mean that. In some situations it will. We'll get into how we identify that as we progress. Okay? Next one.
Oh, this time you give us the sample.
I am going to do this one with you because there is one little subtlety here. The next one I'll have you do at least the beginning of it by yourselves. Okay, what did we say? Now notice they didn't give us percentages here, did they? They gave us the actual mass number, which is fine. It saves us the thought of taking the percent and just making it in grams, right? So we know the grams, we don't have to worry about percentages. Right? So what do you think we do?
Where's the mole?
You do 3.156 divided by.
What are you saying over there?
Who knows?
Let's convert that to moles because empirical formula is a mole ratio.
Pretty much.
Yeah.
It's what it is. It tells us the ratio of each thing to each other.
Yeah.
Each one, two,
Alright, anyone got nitrogen memorized?
14.
Look at you guys.
0.01.
Carbon and hydrogen, carbon, and nitrogen all are 0.01.
Corbin blue.
Did I say Corbin?
You said
Yeah.
Corbin.
Okay? What mole numbers do we get?
0.122.
I'm gonna go a little bit further. That's not a big deal. We'll do that. Yep. Next one.
Something.
0.1972. Oh no, 0.173. Had you want to go there?
I can already tell by looking at this isn't going to give us two whole numbers.
You're right. 1/3.
Nope.
Yes. Well,
Nope.
rounded
Yes.
to.
Okay, what did I say the next step was?
Rounded
To
to.
divide by the smaller number.
Divide by the smaller number,
Rounded to.
because that gives us our simplest whole number ratio. Well, it actually isn't going to give us our simplest whole number, but this is going to give us our simplest ratio. This is going to be 1.
1.5.
What is this pretty closely round to?
1.2. Well, it's 1.
Good
Nice.
night. What is wrong with you?
You're just on a roll.
Right? So you got to think fractions in your head because it won't always give you whole numbers. So you're probably thinking, well, what do I do? Do I do N1, O 1.5? You think that's my answer?
Nope, you go 2 and 3.
Shoot.
Oh, that's what I meant to say, 2/3. Yeah, I was
So
thinking.
I'm going to take both of these
1/3.
and multiply them by 2. And again, remember, I can't just multiply one by 2 and not the other because if I do one by 2 and not the other, I'm not maintaining the what? The ratio. Okay? So, is it possible that your simplest whole number ratio doesn't have a 1 in it? Is it possible
Yes.
to have the simplest whole number ratio not have a 1 in it?
Yeah.
You can't reduce that anymore. It doesn't have a 1 in it, does it?
Oh.
Okay, so what happens if you get something that looks close to like 1.334 or something?
Probably just multiply by 3.
You probably need to multiply everything by 3. What about, I don't know if this will ever happen, but if you ever get 1.256? Yeah. And I doubt 4 will happen because 4 is multiple of
grasp.
anyways.
Dang
Okay,
it.
so if I were to, we got 13 minutes, so if I were to like quickly do like a step-by-step analysis of what you would need to do, the very first step would probably be percent to, unless they just gave you what? Grams. So if it's 73% something, you would just say, I'm going to see grams of that substance. Second step, if I were to list it out, would be what?
That's small.
Convert 2 moles.
Oh, so close.
Number 3, what would be our third step?
Divide by small.
Divide by the smallest.
Oh, okay.
Pretty simple.
I just took it an extra step.
Yeah.
And 4, write empirical. Before you would write empirical formula, you'd first have to ask yourself the question: do I need to multiply by a factor? So how should I write this?
Do I multiply
3
by
and a
a
half.
factor?
Said 3 and a half.
Multiply question mark? Multiple? Multiple or
Multiply. Sorry.
multiple? Multiply?
And then
Solve.
I don't think that's how you spell empirical.
There's an M.
There's an M.
E-M-P-I.
Empirical. Empirical.
E-M-P-I-R-I.
Is it an I? I thought that looked goofy too.
Yep.
Empirical formula. I'm gonna have a 6, but I haven't talked about it yet. Ready? To do the next one? I want you guys.
I'm learning.
I want you guys to get to empirical formula. That's all I want at this point. There's another step that I'm going to teach you, but you guys should be able to get to empirical formula with this new guy.
Good.
Good job, Eddie.
Eddie.
That's my nickname.
Good.
My grandpa
Yes.
always called my mom Fred.
Need some paper and I don't want to get some out.
Why? Because I made you do 4 of them? Good. Jolly Jeffrey.
Good night.
Oh, Jeffrey.
Hey,
what? Just saw that. I was like, wait, there's another one.
John.
I'm gonna call Miss Grimmer.
Answer it.
You got an answer already?
Answer it on speaker.
Oh, you're getting a call.
Tell me what number you have speakerphone.
640, 1812.
Speakerphone. Answer it.
Oh.
Answer. Oh.
I should have answered it. Just
Okay. What do you do?
I'm gonna do this all like I could.
Wait a second.
I'll try to.
Well, I don't have.
What's this?
I need like little sticky notes.
How do you go from percent to grams? I can't.
Oh my
Okay,
you
calm
just
down. I
switch the
wasn't
percent and make it a G.
Oh, is it a Okay, you know what? Wait.
That's she's rolling down that hill.
I am.
Jenny, now you're going the same way as I am.
What was that, Rachel?
Why is the more massive?
See,
To get to the mole ratio.
Wait.
1.
why does it say percent
To get to the
grams?
mole
It needs to be
ratio.
grams.
To get the mole, so you can find the mole ratio.
So these are the grams. Just it says percent.
Did I already lose you guys? You don't know what you're doing?
I am. I got it. Well,
Take this percent. Just change it to grams. Take this percent and put a little G there.
Why?
Because
How do you know? How do you know there are 100 grams there?
you don't, but you're choosing 100 because it doesn't matter the
What
amount.
if I want to choose something?
That'd be really hard.
Okay.
Yes.
This is easier than a piece of junk.
Yeah, I would
Or a
round that
piece
to
of
5. But then, yeah.
What is hard about it is a jump. First one.
You need to finish by writing your
I should
empirical
have
formula.
rephrased that.
Yeah.
Yeah.
Now you're probably wondering, how do I write this?
Okay.
Like which element comes first? I'm just going to tell you now, carbon's usually first, oxygen's usually last. It usually goes by electronegativity values. So carbon, hydrogen, nitrogen, and oxygen in this situation.
What?
Oh, this is gonna be clean. Yeah. Thank you.
good day today. It's a good day.
Hope that works.
I got it down.
Have that freshman.
I haven't.
We need to get big enough.
Our
We need a
freshman
third
was that
science teacher, so I can jump physical science on some other teacher and like have an advanced physics or like an engineering class. That would be sweet.
Sorry. It goes by electronegativity, you said? But that's just why
Did you say
Is it nitrogen or
I
electron?
think that's right, Tanner. You got 4, 5, 2, 1?
What's the order?
Mr. Grum's on
4,
for
2,
this.
5.
Yeah. Well, these two would be flipped, but that's okay. I'm not gonna die.
Okay.
Oh, shoot.
What order?
It usually goes from lowest electronegative to highest,
But is it
which
nitrogen?
carbons are typically the
Oh, it goes
first.
lowest.
Yeah. So carbon, hydrogen, nitrogen, oxygen based on electronegativity.
Oh, yeah.
Carbon has the lowest of
No.
Wait,
all
wait,
of
say it again.
Carbon, hydrogen. Right? The only two that would be harder would be carbon, hydrogen, because we know nitrogen's more electronegative than carbon, and oxygen's more electronegative than nitrogen. Typically, carbon's always going to be the
Right.
first. Yeah. How we coming?
What did you get?
Let's go.
Wait, what? Oh, that's a 2 times the same.
That's it.
One try.
It's kind of busy work. It feels more like math than science.
Yeah, I don't like it.
Yeah, exactly.
Why? It's so easy.
I didn't want to
Sequential
take math
steps.
this
I
year.
don't like that.
Ugh.
Why are you
But-
taking it next year then? Because it looks
Ooh.
on transcript.
You gotta take
I
these.
might not take it
Am I
next
supposed
year
to?
anyway.
Yes.
I think I'll take it senior year too.
Am I supposed to?
Yeah, if it's really close to a whole number, make it a whole number.
Okay.
Gage, shut up.
So all you're looking for, guys, when you're doing this,
Already done.
if it's close to a whole number, make it that whole number. Or if it's close to your typical fraction, like if it's close to 0.5 or like 1.5, then you would round it to 1.5.
Yeah.
You can round it to your nearest fraction if it's not a whole number.
Mr. Kramer, you like this? Oh boy. This is the molecular.
That doesn't even look right. I don't even know how to do
Yeah, you figured it out. You figured out how to determine the molecular formula.
Nice.
Because if you look up here, did it ask you at all to find the empirical formula?
Dude.
No, it didn't. So you're probably wondering, why'd you make me do that? Well, you need to know the empirical formula in order to solve the molecular formula.
In this case, is it the empirical formula?
It is not. They're not the same, and I will show you how you determine them. Is that right?
Just show
Okay. So the empirical formula you should have got was like C5H4N2O. Is that correct?
C4H5.
You're an empirical.
Ah. I was just guessing. I couldn't remember. Did we get this?
Yes. Imperial.
Yeah.
That's the
Okay.
Oh, it's the molecular. What's the
This is the empirical formula, and I want to figure out, is this also the molecular formula, yes or no? Okay, I know you know, but don't say anything.
No, it's not.
How do you know?
Because you just said it.
Did I?
You did.
Yeah,
No.
I asked that.
I said sometimes.
You said
No, I literally asked you. You said it wasn't.
You have to add up.
Shut that up.
I thought I was doing.
Okay? Anybody else? You are doing great. I'm glad you know, but I want other people to think.
Trying to.
Okay? So, how do you think, anybody other than Gage have any idea how you might figure out if this is the correct molecular formula or not?
How do you know the molecular formula?
Yeah, what's that? Yeah. Sorry.
The the correct formula.
Look it up on Google.
That essentially molecular formula is the correct formula for that particular thing.
CHO.
It can be the same as the empirical if the molecular is the simplest whole number.
Not the simplest ratio.
Yeah, but it could also be the simplest
So
ratio.
this just can't be.
Right? Remember how I talked about how molecular and empirical can be the same, but not always? Yeah, it's both. Okay? But C2H4, the molecular formula is that. The empirical formula would be the reduced version of that. Okay? Is there anything up here that is new information that we never saw in the other problems?
last molar mass.
Okay, so that's probably important in figuring out if it's the correct molecular formula or not. It says caffeine molecule has this for a molar mass. So we know the molar mass of the molecular formula. How will we be able to tell if this is the molecular formula?
Add all, yeah.
Find the molar mass of this, and if they're the same, what could you assume?
That's the molecule.
That is the molecular formula. If they're not the same, then you're going to have to do a little bit more work.
Oh.
So let's see if we can memorize this. 4 times what is carbon?
16.
No, carbon is 12.0.
12.0.
Plus 5, what's hydrogen?
1.01.
Plus 2, what's nitrogen?
1401.
Plus,
16.
okay. That will give us the molar mass of this.
97.11.
Yeah. So just double the molecule.
Now, this is not the same as this, but we know the empirical formula will always be a multiple, or the simplest multiple of the molecular formula. So we should be able to just multiply it by a whole number to figure out what we have to do. Double it. If I take this and multiply it by 2, it gives me this, which means it's twice this, which you mean I'd have to do what?
Double. So C to the
C,
H.
H,
H10, N4O2. Yep.
Yay. And we have one.
That was beautiful.
That was beautiful, Kramer.
This is one of our better days of
Yes.
getting stuff done.